Hello everyone, and welcome to this explainer. If you're building or scaling distributed systems right now, you are probably swimming, maybe even drowning, in a sea of event-driven terminology. You've got CDC, event streaming, event sourcing, and this whole ecosystem of tools that claim to do it all. But using the wrong pattern for the wrong job, that can literally lead to architectural nightmares. Okay, let's dive into this and untangle these overlapping concepts once and for all so you can design systems that are actually both resilient and accurate.
So where did your data go? I want to start by poking at a core pain point we all face in software engineering. Think about a traditional database for a second. Every single time you update or delete a record, what happens? Poof, that historical context is erased forever. If you change a customer's address from New York to London, the database only knows they live in London now. The fact that they ever lived in New York, or more importantly, why they moved, gone. In a world where data is our absolute most valuable asset, overwriting it like that is just a massive loss of intelligence.
And this brilliantly illustrates the fundamental shift we're talking about today. Consider traditional CRUD: create, read, update, delete. It is purely state-based. It only tells you where things stand right now. But then look at the event-driven, intent-based paradigm. Instead of just storing the final state, we're actually storing the journey. We capture the complete history, the behaviors, and the precise intent behind every single action. But, and this is a big but, how we capture and move those events makes all the difference.
Section 1. CDC, Watching the Database, the System-Level Observer.
All right, think of Change Data Capture, or CDC, as a security camera quietly watching just outside your data layer. It relies entirely on the underlying transaction logs, like MySQL's bin log or Postgres's write-ahead log. It monitors these logs and fires off a system-level message every time a row is inserted, updated, or deleted. So the crucial point is that you don't have to touch your risky legacy application code to get these events. The database doesn't even really know it's being watched.
Let's rapidly fire through the pros and cons here. On the plus side, CDC gives you incredibly reduced latency for data ingestion, it's completely decoupled from the app, and again, zero risky code changes to your legacy systems. Huge win, right? But the drawbacks are pretty significant. First off, it's highly database specific. Second, it is super vulnerable to silent schema changes that can break downstream systems, and trust me, nobody wants to be debugging that at 2 a.m. But most importantly, CDC captures database events, not business events. It essentially exports denormalized noise. It tells you a column changed from a 0 to a 1, but it absolutely doesn't tell you why. Was it a customer canceling an order or just an admin doing routine maintenance? It completely lacks true business meaning.
Section 2. Event Streaming, the Pipe, Data in Motion. Let's move to and see how this builds into the communication layer of our architecture.
So, if CDC is the camera, event streaming is the cable transmitting the feed. Event streaming is a data processing paradigm that's all about data in motion. It relies on a publish and subscribe model to completely decouple the systems generating data from the systems consuming it. When you need to react instantly, like say catching a fraudulent transaction the absolute millisecond a credit card is swiped, or updating a live social media feed, event streaming is your go-to. Publishers just push events into the stream, and then any number of independent subscribers can read and react to them at their own pace.
Now, what's really interesting about this slide is that streams act as a high-speed conveyor belt. Tools like Kafka or Pulsar, they are phenomenal pipes. They are built to be highly available, fault-tolerant transport mechanisms for moving millions and millions of messages continuously. But they are pipes, not durable databases. They are optimized to keep data moving and generally only keep very short histories. They just aren't designed to be queried like a traditional database.
Section 3. Event Sourcing, the Ledger. State as an immutable sequence.
This brings us right up to the application state level. If we want our events to actually be our database, we look to event sourcing, where we treat our data like an append-only accounting ledger. In event sourcing, you do not store the current state. So the crucial point is that the sequence of immutable domain events stored in a journal literally is the state of your application. Every business action is appended to this journal. To figure out where you are, you simply replay it.
Software architect Martin Fowler has a really brilliant analogy for this involving shipping on the high seas. Imagine you have a tracking app. The ship King Roy departs San Francisco. The ship Prince Trevor arrives in Los Angeles. King Roy arrives in Hong Kong. If you just used a standard CRUD database, your system only knows that King Roy is currently in Hong Kong. But with event sourcing, you have a ledger of every arrival, departure, and load event. You don't just know the ship's current port, you know its entire, complete journey,
exactly how long it took, and what exact route it sailed.
To actually make this work, applications use what's called a rehydration sequence. When a new command comes in, step 1 is to read all past events for that specific entity directly from the event stream. Step 2, you apply them sequentially to rebuild the current state in memory entirely from scratch. Step 3, you run your new business logic against that rebuilt state. And finally, step 4, if the logic passes, you append the brand new event to the end of the journal. You have absolute certainty here because you just proved the state by recalculating it yourself.
Section 4. The big mix-up, streaming versus sourcing.
This brings us to the climax of our explainer, and quite frankly, the most dangerous architectural anti-pattern in the industry today. As software architect Oscar Dudich emphatically points out, event streaming is not event sourcing. People see that both patterns use the word event, right? So they try to use event streaming tools as their event sourcing database. They try to use Kafka or Pulsar to store their permanent application state. Let me tell you, this is an illusion that will absolutely eventually break your system.
Now, what's really interesting about this slide is how clearly the hard lines are drawn here. Event sourcing is about data at rest. It's a database that permanently stores all events to rebuild application state. Event streaming, on the other hand, is about data in motion. It's a real-time processing pipe that generally keeps a short history. They integrate beautifully together, for sure, but they are entirely different jobs.
When you try to use a streaming pipe as your source of truth database, you hit a massive wall. Streaming tools just don't natively support optimistic concurrency, which basically means if two users try to update a record at the exact same millisecond, the pipe literally doesn't know how to reject the conflicting update. You end up with stale data in your materialized views, out-of-order messages, and you are forced to build massive, complex workarounds just to guarantee basic data integrity. Total headache.
And just to complete the picture, we also can't confuse sourcing with CDC. Event sourcing lives at the application boundary. It captures rich domain events like order placed or payment processed into a specialized journal. CDC lives at the system boundary. It merely captures generic change events like row 5 updated straight from the database transaction log. Sourcing is about business intent. CDC is just about infrastructure syncing.
Section 5. Building the modern system. Tying it all together. Let's move to and see how this builds into the modern tech stack.
So how do we actually tie all of this together without duct taping a dozen different tools to our infrastructure? Well, historically, we've used a bolt-on architecture. We take a traditional CRUD database, and then we bolt on polling, triggers, or a CDC tool to extract the events, and then we pipe them into a streaming platform. It's kind of brittle. But the modern approach is the event-native database. Take purpose-built tech like Current, for example. In an event-native system, the history, the replayability of event sourcing, and the real-time push of event streaming are all built natively right into the database itself. You literally don't bolt anything on.
And this brilliantly illustrates exactly why this matters for the future. Look at modern use cases like Agentic AI. If you want an AI agent to truly learn and adapt, it can't just look at the current state of a user's profile. It needs a multidimensional understanding of history, every single action the user took to get there. Event-native platforms provide that deep context right out of the box. They also natively power scalable microservices and local-first sync engines because the database is fundamentally designed to communicate state changes in real time.
I want to leave you with a final question to ask yourself as you look at your own distributed architecture. Are you just moving events around through pipes to update materialized views? Or are your events the actual, immutable truth of your system? Understanding the difference between observing changes, streaming data in motion, and sourcing your application state really is the key to building resilient, intelligent systems. Thank you so much for watching this explainer, and we will catch you in the next one.